Hi guys, I wanted to give you a video to practice how to graph quadratic functions. And again, it's a step-by-step process. First thing we're going to do is figure out the axis of symmetry using the formula x equals negative b over 2a. That's going to tell me the center of my parabola. It also tells me the x-coordinate of the vertex. From there, I'll figure out the y-coordinate by substituting in that x-coordinate into the original equation and solving. Then I will come up with a t-chart with 4 more points. I'm going to very specifically choose my points to be 1 above, 1 below, 2 above, 2 below my x-coordinate of my vertex. And then when I calculate my y's, you should see some repeating going on with your y values. And then I also am going to calculate my X intercepts. Alright, so we're going to go over the one we did in class. And we're going to go ahead and graph. Oh, sorry, changed my color. Back to black. Directions are going to say graph. Calculate X intercepts as well. So the first one we did today was y equals x squared plus 6x plus 8. So first thing we're supposed to do is get this equation into standard form, and standard form for quadratic equations is the f of x equals ax squared plus bx plus c. And if you notice, A would go in front of here, B would go in front of here, and C would be the last guy. So what we're going to do is just write those out. In front of the x squared is 1, in front of the x is 6, and in the constant, the number without a variable, is the 8. Now in the formula we're going to be using, we're not going to be dealing with the C value, but I do want you to pay attention to where he's located. And you also have to pay attention if there's a missing term. You can't just, who's ever next to x squared is b. Nope, you have to be associated with the x to be the b term. The c term doesn't have a variable attached. So the formula for the axis of symmetry is the vertical line. So it's going to be x equals, and it's equal to the negative b value over 2a. So in our problem, we're going to put the negative of 6 over 2 times 1. That gives me negative 6 over 2, and we get x equals negative 3. So again, this plays 2 roles. It plays the axis of symmetry, so the center of my parabola, because I'm going to use this notion of symmetry when I'm doing my graphing. The other thing that's super important is it does tell me the x-coordinate of the vertex. And the vertex, remember, is the uppermost or bottommost to lowestmost point, depending upon what direction my parabola is facing. So the vertex, I've already got half of it. I've got the x-coordinate, and my job is to figure out the y-coordinate. Well, that's really simple to do. All I do is I substitute in negative 3 back into the original equation and solve for y. So I'm going to get negative 3 squared plus 6 times negative 3 plus 8 gives me 9 minus 18 plus 8 for a grand total of negative 1. So I'm going to take that value and plug it back in, or plug it into the vertex coordinates. Now I'm going to take that idea of my vertex, and I'm going to put him in the center of what I call a t-chart. And a t-chart is basically a way to organize the order pairs you're going to do. So we're going to select x's, and then we'll calculate the corresponding y's. So how I do it is I figure out one number that's greater than the x-coordinate of the vertex. So one greater than negative 3 is negative 2. And then I pick one that's one less than negative 3, so that'd be negative 4. And then 2 greater than negative 3 is negative 1. And 2 less than negative 3 is negative 5. So those are the x's I'm going to choose. Now to calculate the y's, I'm going to go ahead and plug them back into the original equation. So the value of my function when I have negative 2 in for x gives me negative 2 squared plus 6 times negative 2 plus 8. And that gives me 4 minus 12 plus 8 for a grand total of 0. So what you're going to see is I'm going to take that 0 and put it in with the negative 2. Now, because I've chosen symmetrically that all of my numbers are equally distant from the vertex, what happens when I plug in negative 4, which is 1 less than the vertex, you're going to see a little miracle happen. So that's going to give me 16 minus 24 plus 8, which also gives me a grand total of 0. This is by design that this happens. This isn't some sort of coincidence. Also, those numbers should kind of strike something interesting in you. All right, let's go with the other two. So we have f of x, the function of f at negative 1 is going to be negative 1 squared plus 6 times negative 1 minus, or plus 8, which is going to give me 1 minus 6 plus 8, which, gives me negative 5 plus 8, which is 3. And when I plug in the f at negative 5, I'm going to get negative 5 squared plus 6 times negative 5 plus 8, which gives me 25 minus 30 plus 8, which is negative 5 plus 8, which equals 3. So what we saw here, where those guys match and those y's match, that is always going to happen, provided that you pick your x values so that they are exactly the same distance away from your x-coordinate of your intercept. Alright, so what I'm going to do is go to the next screen, and we're going to take those 5 points and we're going to graph them. So let's see, we're going to graph, oops. Negative 5, 3. We're going to graph negative 4, 0. We're going to graph negative 3, negative 1. We're going to graph negative 2, 0. And we're going to graph negative 1, 3. Now, one more thing I'm going to do before I get there, I'm going to go ahead and calculate the X intercepts, which takes us back to chapter 6, which says take your function, set it equal to 0, and solve. So when we play the game, factors of 8 that add to give me 6 would be a positive 4 and a positive 2. Because my quadratic coefficient is equal to 1, I can put those factors right into my binomial. So I get an x plus 4, x plus 2 equals 0. So we'll take each factor that contains a variable, set it equal to 0, and solve. Subtract 2 here, so we get x equals negative 4, x equals negative 6. So this tells me where my parabola crosses at the x-axis. And in most parabolas, it's going to be 2 times. So what you should notice, we had actually inadvertently calculated the x-intercepts when we had chosen our x's. Alright, so let's get to the graphing. So let's see, I've got a bunch of negative x's, so I'm going to do my graph kind of funky. Let's see, I have one negative y, and the rest are positives. Let me make this a little longer. So here's the x-axis, here's the y-axis. We're going to go up 1, 2, 3, 4. Label every other one. 1, 2. Label every other one. 1, 4, 5, 6, Make sure you got the negatives in the negative direction. Okay, so negative 5, 3. I'm going to graph these in red. It's right there. Negative 4, 0. Right there. Negative 3, negative 1. Oops. Right there. Negative 2, 0. Right there on the axis. And negative 1, positive 3. So if you notice, I have two sets of points that are directly opposite each other. And that's because of the way I chose my x's. Now here comes the tough bit. When I'm graphing, I do what I call sketching. So sketching is kind of fluid motions trying to get a curve. Now parabolas are continually getting larger, and eventually on the right side it's going to intersect the y-axis. But for our purposes right now, this is what I'm interested in. Okay? Alright, let's do one more. And we've got y equals 5 minus 2x squared. So number one thing is we must put it into standard form, and standard form has ax squared, so the squared term comes first, plus bx, so the x term comes second, plus the c. So when I rearrange this, the negative 2x squared goes in front, and if you notice, this next term has a 5. There's no variable attached to it, so what I could do is put in a phantom x term with a b in front of it, and then write out the rest of the equation. And what that may help me do is pick my a, b's, and c better. So a is negative 2, b is 0, and c is equal to 5. So again, I go to axis of symmetry. Which is x equals the negative of b over 2a. And for us, we plug in the negative of 0 times 2, divided by 2 times negative 2. So here's what's super important, is that you guys put your b value in parentheses so that if he's negative, there's still that negative on the outside. So what we get is 0 over negative 4 for a grand total of x equals 0. So if you think about it, x is a vertical line, and it goes through 0 on the number line, which means our y-axis is actually our axis of symmetry. So again, here's another way to look at this if you're having trouble picking your values. Actually, no, hold on. I'll get to that in just a second. Let's go back and let's go ahead and do the vertex. So already we have the x value of the vertex, and now we're going to plug in 0 in for x and solve for y. So 5 minus 2 times 0 squared gives me y equals 5. So I'm going to take that 5, put it in, and now I've got my vertex. So when I get ready to do my t-chart, I have x and I have y, and I'm going to put my vertex in the center. Okay, so let me go back to what I was just about to tell you, and then I stopped myself. Okay, so I want a total of 5 points on my to graph, and so what I'm going to use is my vertex as the center point, and then I'm going to pick one above it, one below it, one above it, one below it. And so if you look at this one, it works out to be those 5 numbers. So I'm going to be picking, let's just use negative, oh look, go the other direction. Positive 1, positive 2, negative 1, negative 2. And what we're going to do is math, and what we should remember from the last time, because I'm picking integers that are equidistant from the vertex x, I actually only need to focus in on coming up with those answers, and then they're going to be mirrored on the other side with the negative 1 and negative 2. So I'm going to go ahead and do y equals 5 minus 2 times 1 squared. Gives me y equals 5 minus 2, which gives me y equals 3. So 3 is going to go with the 1. It's also going to go with a negative 1. And you can see the logic of that. Negative 1 squared is 1. Negative 2 times 1 is negative 2. 5 take away 2 is 3. So nothing changes. Let's go with another value here. Let's go with the 2. So y equals 5 minus 2 times 2 squared. So we're going to get y equals 5 minus 2 times 4, which is y equals 5 minus 8, which gives me a negative 3. And if I get a negative 3 there, then I'm going to get a negative 3 at top. Now, something else you might notice is look at the direction that your y's are going from the center out. They're going from a positive to smaller, okay? So let's double check here. If I put in negative 2 squared would be 4. Negative 2 times 4 would be negative 8. And 5 times negative 8 equals negative 3. So those are the 5 ordered pairs that I'm going to graph. So let's go to the next slide. And let's do things a little differently than the last time. Let's go ahead and do the X intercepts. So what we were told was to take our equation, we can go back to it written in the original way, set it equal to 0, and then we're going to solve. Now this one is interesting because I don't have a linear term. I can solve this the way we talked about in Chapter 5. So we're going to isolate the squared term. Oops, that's negative x squared equals negative 5. Divide both sides by negative 1. I get x squared equals 5, and then I take the square root of both sides. Now, there's 2 possible answers, remember, when I take a square root. In fact, I'm going to erase that and highlight that in red. I get the square root of x squared is x equals plus or minus the square root of 5. So I have actually 2 possible answers. Now the problem, this is why I don't choose to use intercepts as a primary way of trying to figure out ordered pairs and whatnot. I don't know how to graph that. So I can estimate that, and estimating would not be to the nearest integer. It'd have to be to the nearest tenth on this one. And so we could get a ballpark idea. So we're going to just do that just for our practice. So that guy's between 4 and 9. Square root of 4 is 2. Square root of 9 is 3. He's definitely closer to the square root of 4. So I'm going to guess small numbers like 2.2. So I get 4, 4, placeholder 4, 4, and I get 4, 8, 4. So 4.84. That's close. Let's try 2.3. So I get 9, 6, placeholder 6, 4, and I get 9, 12, and so that's close. So it turns out that it's somewhere between 2.2 and 2.3. In fact, it's what? 0.16 away from 2.2 and is 0.29 away from 2.3. So when we graph this, our answer should be a little over 2, okay, not halfway, but a little over. So let's see how it works. So let me pull out my ordered pairs. We've got -2. Oops, did I make a calculation error? I think I may have. Let's go back and let's see what I did wrong. I got, let's see, I picked 1, and I got, no, that looks right. Picked 1, yep, okay. Picked 2, just double checking I had something written down on my paper that's different. Okay, so I have 2, -1, oops. Let's see, we had -1, 3. Oh, nope, sorry. That's supposed to be -3. So Sorry, I have to write it. Sorry about that. And then we had 1 positive 3. We got the vertex of 0, 5. Oh, that's negative 1, 3. 0, 5. And then we had 1, 3, and negative 2, negative 3. Positive 2, negative 3. Sorry, brain. All right, let's go ahead and see if we can graph this. So let's see, my y's, both directions, and my x's are pretty evenly spaced out. I go a little higher on the y-axis. Okay, so in red, we'll get our dots. So we're at negative 2, negative 3. We're at negative 1, 3. We're at 0, 5. We're at 1, 3. And we're at 2, negative 3. Okay, so again, I'm going to sketch this. Let's see. Well, those order pairs don't look like they go where they're supposed to go. I think part of that is because this is when you don't use graph paper. You're never going to get things exactly where you want them to be. And so I don't have my intervals aren't equal, so that makes sense why they may not be hitting the way they need to. But those, if I was using graph paper, this would be more dead on with my graphing. Okay? All right, so here's something interesting. If you look at the last graph, look at how it looked, and look at what its equation was. You had x squared plus 6x plus 8, and look at what your graph is. It's full looking, it's pointing upwards, it's dipped below, the vertex is below the x-axis, that's a minimum over there. And then we look at this one, our equation was 5 minus x squared was equal to it. It's facing downward, it's skinnier, the numbers shoot up quickly. Yeah, kind of strange looking here. And look at where your axis of symmetry is. It's right there on the y-axis. So I want you to kind of start looking at your equations and seeing if there's a relationship between what your graphs look like and what your equations look like. All right, good luck with your homework.